Okay, last part of this section are higher order derivatives. So the derivative of a function is itself a function, so we can find the derivative of a derivative. The new function obtained by differentiating the derivative is called a second derivative. And we can continue on to get a third derivative, a fourth derivative, and so on. And these are referred to as higher order derivatives. So for example, if f of x equals x cubed, then f prime of x equals 3x squared, and then we're going to look at the second derivative. The derivative of f prime of x would be 6x. And if I did a derivative of the second derivative, which would be a third derivative, I would get 6. And then finally, the fourth derivative, 1, 2, 3, 4, is 0. And anything after that's going to be 0. Okay. So look at the notations of higher order derivatives. We can use our prime, f prime marks, and sometimes you'll see, especially when we start getting into the higher numbers, you'll see the numbers. Could be y. We could use the Leibniz notations, d2y, dx2, d dx, dy dx, and again, you can see where we would put the different numbers depending on the derivative. So again, these are just some notations for those higher order derivatives. What if we're looking for acceleration? The position of a particle along a coordinate axis at time t in seconds is given by s of t equals 3t squared minus 4t plus 1. So we're given our position function in meters. Find the function that describes its acceleration at time t. Well, we need to find s prime of t, which remember that gives us our velocity. The derivative of a position function is the velocity. The derivative of the velocity function will be the acceleration function. So the first derivative of the position function will give us our velocity function. So we would 6t minus 4 using our limit definition of a derivative. Then we do the second derivative of the position function, which is acceleration, and we would get our acceleration, which would be 6. So the position function, the first derivative is your velocity, and the second derivative is acceleration.